We'll get going here in just a minute, folks. We're making sure we've got both recordings going and everybody.
My apologies. I figured it out. I didn't actually click on the YouTube page.
Okay. So I will get started. Welcome back, everyone. Happy rainy Thursday, May 14th, 2020. What's up in the sky this week? There are some neat things to look for in the sky this week. So you always want to be prepared to go outside. Now, if you're going to go outside and do some observing in the backyard or the side yard or the front yard or wherever you are, when it's still light out, take a little walk back to your observing spot and just make sure that there's no holes or rocks or bicycles laying there that you might trip on, because you don't want to bring out a flashlight. You don't want to have a flashlight necessarily because it ruins your night vision. So just make sure you're not going to trip on your way out. Get permission from an adult and go out with an adult. You really don't want any white light. The white light ruins your night vision, and then you go to look up in the sky and you can't see anything even though the stars are there because your pupils contracted. Now, if you have some kind of a red cellophane or fabric that you can put over a small flashlight with a rubber band, that's much better for your eyes. So a red cellophane covered flashlight is okay. Everything I show you today is visible with just your eyes. You will not need telescopes. Now, the theme of the program today, I hope I have lots of kindergartners and first graders and second graders and third graders, because the theme is what's in the sky. Now, that seems pretty simple because I go outside and if I lay down on the grass and look up, sometimes it looks like this. You know, I see the clouds and the trees and the leaves. Those things are all up in the sky. But wait a second. Is the tree really up in the sky? What about this tree? Look how high up those leaves are on this palm tree. They are up high in the sky, but this tree is actually attached to the planet Earth. And the planet Earth is not out in space. So I want to make sure that you know that we are not going to study things that are actually part of the Earth. That palm tree is actually not out in space. What about airplanes? They're up in the sky. This one here in the blue background, that one's up really high in the sky. I can see the condensation trails behind it. Does that mean it's out in outer space? Nope. Planes are in our atmosphere and that's part of the Earth. So those things are not something that astronomers or space scientists study. What about insects? You know, bees and flies, and what about birds that fly over your head? Are they in outer space? Nope. But what about the clouds behind him? What about the sky up there behind the bird? Is that outer space? Yes, it is. The bird is not out in outer space. And what about this one? I love this picture of the sky. I see the clouds and the blue and the sun. Well, are those things in outer space? No and yes. Clouds are not out in outer space. Clouds are part of the atmosphere, so they're part of the Earth. But the sun is definitely part of out in space. The clouds are so much closer to us that sometimes they can block out the light from the sun and make it really cloudy like today. Like if you go look out the window right now, you're not going to find the sun anywhere. But it's there. It's on the other side of the clouds. I can tell that it's there because when I go outside, it's so bright. I can see without a flashlight or turning any lights on because I know the sun is up there behind the clouds lighting them up. Now I've got a game for you. It's called Name That Thing. I'm going to show you a picture like this. I'm going to give you a moment to think. Do you know what those things are? Yep, they're planets. If you said planets, you are totally right. You are on the ball. Those are the planets in our solar system. So what about this specific one right here? I'll give you a hint. This one looks kind of like the moon, but this is not the moon. What do you think it is? If you thought Mercury, you are absolutely correct. That is the planet Mercury. That's the one closest to the sun, and it's super, super hot during the day and super, super cold at night. Here's the next one. Do you know what this is a picture of? I'll give you a hint. It's not the sun. This is definitely not an image of the sun. It's sometimes called the Earth's twin. If you were thinking Venus, you are correct. Venus and the Earth are almost exactly the same size. And Venus is up in the sky tonight. Boys and girls, I want you to know that up in the sky, when you go outside, Venus never looks like this with your eyes. This is a telescope picture of what Venus looks like. This is what Venus looks like in the sky when you go outside tonight. It looks like a really, really extra bright star in the west. If we could zoom into it tonight, that's what it looks like. Venus is actually a tiny little crescent shape tonight. Venus is up in the western sky. Okay, here's the next one. Do you know what this is? If you said planet Earth, you are absolutely correct. That is definitely the Earth from space. Here's another picture of an object from space. This one has the largest volcano in the whole solar system, named Olympus Mons. And if you said Mars, you are correct. And there are no aliens on planet Mars. There's no such thing as aliens. Oh, Mars is visible in the sky tonight. Again, Mars does not look like this when you look at it with just your eyes from Earth. If you have a telescope, you can zoom into it. It's right above the moon early in the morning. This is 4:44 in the morning. I call that the middle of the night. That's when I'm sleeping. But if I could zoom into Mars tonight, it would look about like that. It has two moons named Phobos and Deimos. You can see those in a telescope. Okay, here's object number 5. Can you tell what it is? This one has something called the Great Red Eye, or the storm of Jupiter. And you know that eye on Jupiter has gotten way, way smaller in the last 10 years. You used to be able to fit about 4 Earths across, or is it more than that? It's shrunk over half in size from one side to the other. Nobody really knows why. Here's what it looks like if you zoom into it with a telescope. Jupiter's right in the middle, but what are all those other dots? Those are Jupiter's moons. If I zoom in a little bit more, we can see Jupiter, and Io is the name of its closest moon. Okay, what is this? I see 2 moons of this one, and it has big rings. That, of course, is planet Saturn. Yep, some people call it their favorite because those rings are spectacular. Here's what it looks like if you zoom in on Saturn. Wow, do you notice all those moons? Those are all small rocky objects that go around Saturn. Those are Saturn's moons. That's a telescope picture of Saturn. So hey, what's this one? It's bluish. It's tilted on its side. It goes up and down like that when it spins. And if you were thinking Uranus, you are absolutely correct. Here's the next one. It also has an eye, but it's blue, and it's very, very cold because it's very, very far from the sun. Neptune is the farthest planet out from the solar system. I know, you're thinking, what about Pluto? Pluto's still there. Nothing happened to Pluto. Pluto looks like that. What a spectacular image. That's a close-up from New Horizons. And you know, it's got a heart-shaped, kind of white, light-colored object here. We call that the Tomball plane. It's just spectacular that we can see that Pluto has craters on it and slightly different colors all over. That definitely is Pluto. Now, Pluto is a dwarf planet. It's just not one of the regular planets anymore. There's several reasons for that. But Pluto is amazingly small. That's not why it's considered a dwarf planet. I mean, dwarf planets are small, but there's no size limit for planets. You know, it's so far away, about 4 billion miles. When I was a kid, this is how we looked at Pluto. We said, yay, look at, there's Pluto. Because that was the best picture we had in the 60s and I don't know, maybe through the 70s. If I circle Pluto right there, what they noticed was the next night when they took a picture, it's in a different spot. Actually, that was probably more than one night. It moved from being on this to the left of these 2 stars. Now it's on the right. And he said, hey, that thing's moving. It must be a planet. And then we realized it was a planet. It got named Pluto. And here, ooh, look at that picture of Pluto. That's the best one I remember as being a teenager. Wow, look at that. That's Pluto. Well, then in the 90s, the Hubble Space Telescope zoomed in a little more and we said, woo, look at how pretty that is. That's the best picture we had of Pluto through the 1990s. And then we have this one today. It's amazing how far our cameras have come in the last few years. So that's the solar system. Now, notice in the solar system here, we've got Mercury, the one right next to the sun. Boy, that one's hot. And then the second one out right here, this is Venus, which is actually the hottest planet, the second one out. And then Earth is third, but follow the path around the sun. Do you see any of those paths crisscrossing? The word is intersect, but they don't. None of the orbits of any of the planets ever cross each other. That's a planet rule. Oh, one of the other planet rules is there's only one planet allowed per orbit, kind of like one car per road. One planet per orbit is allowed. Like if you look at all these things, they're all on the same orbit. Those are asteroids. We don't call each one of those planets because when there's lots of them in the same orbit, that means it's not planets. We can't call them a planet. Well, it turns out that Pluto, right here is Pluto in the upper right, and that purple orbit, that's Pluto's orbit compared to the rest. It turns out that Pluto has partners. Pluto has Eris, Makemake, Haumea. It has these other rocks that are almost as big as Pluto, and they go around the sun in the same orbit. What that means is all those things are not planets. We have to call them something else. And if you notice in this picture, Pluto's orbit crisscrosses with Neptune's orbit. All of the planets, the 8 official planets, they all go around the sun pretty much in the same flat plane. Think of it like a plate. But then look at Pluto, kind of an oddball how he goes up so high and then down low. So crisscrossing, extra objects in the orbit, those are the reasons, 2 of the reasons why Pluto is not a regular planet anymore, and we call it a dwarf planet. So here they all are. I love this image. This is about how big the planets are compared to each other. So are you ready for round 2? Name that thing. What are these? And if you said moons, you are correct. These are not planets. These are all moons that go around the 8 planets. Do you know how many moons there are in the solar system? The moons that go around all the planets, not just the Earth. There's more than this many. There's more than this. There are about 170 moons right now in our solar system. 170. One of them is named the moon. We give the other big ones names too, but we often call them the moons of Saturn, even though they have their own names. That's a lot of moons. So, which of these moons belongs to Earth? Well, I think you guys know it's that one on the bottom. Yep, that is the moon. I love the moon. I love it when it's full like that. You know, when we can see the whole thing. We can see the whole entire lit part of the moon. Our eyes only work when light hits something or comes from something. So I know when I look at the moon like that in the dark sky, that the sun is on the other side of the Earth behind me. That's what makes a full moon. Sometimes when I go out, it's shaped like this. That is called a gibbous moon. A gibbous moon is bigger than half, but not quite full. We call this one a half moon. It's also known as a quarter moon. And then there's the crescent moon. You know, it's pretty amazing to look at diagrams. And I'm going to go to a diagram here. A couple of them that I want you to see. That's the main page. I'm going to start with this one. I love to put myself way out in the solar system and look at how things move. And I also like to put myself on Earth and notice how things move. So right now we have a waxing gibbous moon. I can take this label off if I want, but I like to leave it on. And look carefully. Does anybody see a waxing gibbous moon here? Nope, we can't see it. That means the Earth needs to keep spinning, so we'll be facing wherever the moon is. And I can make it play. Time goes by pretty fast. Whoa, there goes a day. Oh, there goes the moon. Up, here comes the sun. Up, there goes the moon. I want to stop right here though. This is nighttime, 11 o'clock at night. I can hit the 1 hour forward button. Here's midnight. Here's 1 in the morning, 2 in the morning, 3 in the morning, 4 in the morning, 5 in the morning. Right after the sun rises, the moon sets. And on this same day, we can keep going 9 in the morning, 10, 11, 12, 1, 2, 3, 4, 5. When the sun sets, hey, there's the full moon rising. And if we let this play, we can just keep watching the moon. I wonder what size it will be next. Oh, it still looks full. Let's watch again. I wonder what size the moon will be next. Let's stop it right here. Is that really a full moon? Is it a full complete circle? Let's go forward the next day. Whoa, that was fast. Oh, look, I can tell that this side is a little smaller. It's definitely a gibbous moon. Let's go to the next day. Whoa, hey, it's a little bit smaller, and I noticed it looks like it moved a little bit to the left. Let's go the next day, and the next day, and the next day. Hey, by 1 o'clock in the morning, a week later, the moon is almost half, and it's really low on the horizon. Now, once you play with that one for a while, it's kind of neat to go to this one, because now we're both out in space, and up here, it shows you what you would see from here on planet Earth if everything were in this position here. If you just take a few minutes, you can get rid of details if you want. You can fast forward an hour at a time. Ooh, I can tell this person is right between daytime and nighttime. You know, sunset. And if I fast forward an hour, it's nighttime, and that person can look up towards the moon and see that it's mostly dark and a little tiny bit of it is bright. And the adults that are on here, I'm going to go to the main page. astro.unl.edu is where you can find these. astro.unl.edu. A lot of it uses Flash. If you have trouble getting onto any of these sites, you can email me. And in my presentation here in a couple of slides, I have links for all of these animations that I'm going to use today. So you can go there and find the actual addresses, and you can just click on them. I'll show you how to do it at the end of the show. You know, and this got me to thinking. I went out the other night. Really, this is a picture from my own camera. A couple of weeks ago, it was a gibbous moon, and this was about 5 o'clock in the afternoon. I went out and I saw the moon during the day. That's perfectly normal. If you can't see the moon during the day, that means you won't see it at night. Sometimes when you see it at night, it means you won't see it during the day. But I decided to do a little experiment. I got a ball, a plastic ball, like a wiffle ball without holes, and I stuck a pencil in it. And I went outside and I pretended like that was the moon, and I held it up right next to the moon to see if I could see the phase. I'm going to have you watch the video. Well, before I start here, look, can you tell that this side of my wiffle ball is light, like daytime? And can you tell that this side is dark, like nighttime? Hey, in this picture, could you predict where the sun must be for it to look like that? I mean, look where the shadow is on my body. This side of my body is in the shade, but the back side of my body is getting sun. Doesn't that mean the sun must be shining from over here? Yep. And if it's 5 o'clock in the afternoon, that means the sun is in the west, and my body starting right here is facing east. But let's watch this. Whoa, did you see that? This part is getting sunlight, and it's just a little crescent. I'm mostly seeing dark, but at the beginning of the video, when it was farther over, that crescent's even smaller. As I start moving my moon around the camera, we start seeing more and more of the lit part. Bigger, bigger, bigger. If I stop here, I can see almost all of the lit part and only a little bit of the dark edge. That's a gibbous. And then look, there's the moon. That's where I saw it up in the sky. And it really was a gibbous. Here's the shape that it was. Oops, That's not what I meant to do. Stop. There's a picture of it. There's the moon, and there's my ball that I stuck a pencil in. Hey, can you see that the bottom is dark? But most of it has light on it from the sun. I can even see where the sun's hitting it directly. Hey, doesn't it match the moon? My wiffle ball is dark, just a little bit on the bottom, just like the moon. You guys, they match. Isn't that cool? So here's all those websites. There's links to these in the portal, and I'll show you how to get to the portal in just a minute. Now for more questions. Which two planets do not have moons? There are two planets with no moons. Do you know which two? Venus and Mercury. Mercury and Venus are the two planets that do not have any moons. Those are the two planets closest to the sun. Interesting. Which planet is hotter? Mercury is closer to the sun. Do you know which planet is hotter? It's Venus. Venus is super hot during the day and at night because normally it's covered with a thick yellow atmosphere that holds in all the heat. So at night and at day, it's typically 400 degrees or warmer. On Mercury, it gets really, really cold at night. Okay, next round, they're going to get harder. Name that thing. Do you know what that arrow is pointing at, what we call that? Yep, those are Saturn's rings. Rings are really, really cool. But hey, do you know which 4 planets have rings? Not just Saturn. All 4 of the gas giants have rings. That's Jupiter, Uranus, Neptune, and Saturn. The 4 planets farthest from the sun are huge. Their rock in the middle is molten, and it's only a small part of the planet because the rest of it is covered with thick gases, like a super thick atmosphere. The gas giants all have rings. Now, Jupiter's and Neptune's are really, really hard to see. You need a strong telescope. Uranus's are a little bit bigger than the other 2, but all of the gas giants have rings. Okay, here we go. Here's the next one. What is that? That line in the sky. The official name is a meteor, a rock called a meteoroid that burns in our atmosphere as gravity pulls it down, makes a streak of light across the sky we call a meteor. They're also known as shooting stars. They're sharp and pointy at both ends. They don't really look like this. Does anybody see something else there? There's a fuzzy comet right in the middle. Comets are part of our solar system, just like shooting stars. They're not farther out than our solar system. They're actually pretty close to us. There's another comet in this picture right here. Do you see it? Right there. That is a comet. It doesn't have a tail yet, but it is very fuzzy looking. That's a much brighter comet. You can tell it's not a shooting star. It's fuzzy. It has this long tail that's kind of spreading out. And comets never shoot across the sky. If you see a comet in the sky, you will see it all night long. And what are these things? They're lumpy rocks. They live between Mars and Jupiter. What I mean is they orbit the sun farther than Mars, but closer than Jupiter. Those are asteroids. We don't typically see asteroids in the sky with our eyes. They're too small and too far away. They don't even look like little dots. So here we're going to go a little farther than our solar system. What galaxy is our solar system in? What's the name of the huge group of stars that we're part of? Yes, it's called the Milky Way. That's the name of our galaxy. Our solar system is about right there. It's one little star. And our solar system is in the Milky Way galaxy. And here I have it kind of angled on the side. Our galaxy is shaped, well, a little like a Frisbee. If I look at it all the way from the side, it kind of looks like a line. Here's another picture of a different galaxy that's on its side. That's called the Sombrero Galaxy. Galaxies are round when you look at them from above, but if you look from the side, they can be long and skinny like this. What happens is when we're on planet Earth going around the sun, if you look towards the center of the galaxy all the way to the other side in the nighttime sky, you see lots of stars in every direction, but you see a thick hazy band going across the sky. We call that the Milky Way. Now, don't get me wrong, every single one of these stars in this picture is part of our Milky Way. But when you look through the central band, that's that line that we see across the sky. It almost looks like a cloud. It's not a cloud. Those are made of so many stars so far away, it makes the background glow. And last but not least, do you know what that is? It looks like it has freckles in this picture. It's the sun. The sun gets these little dark things called sunspots. They're cool areas, like little storms that are a little bit cooler than the rest of the surrounding surface of the sun. Man, the sun gives us fantastic heat. Thank goodness it does that, because Earth would be way too cold to live on if we didn't get the heat from the sun. We also wouldn't be able to see. Our eyes only work when light hits something. That's the only reason we see the moon and the planets in the sky, because sunlight hits them. And I love light. I love daytime, don't get me wrong, but I also love it when we're not facing the sun, and we call it nighttime. And that's when we can see stars. Last question, are the stars we see at night part of our solar system? You go outside, you see all those beautiful stars. Are they in our solar system? Nope. There's only one star in our solar system, and its name is the sun. The sun is a star, but it's so close to us that during the day when we're facing it, it blinds us from seeing all the other ones because it looks way brighter because it's so much closer. So we're going to go to that nighttime sky and look. But before I go there, I want you to know that we have a rocket launch scheduled. SpaceX, I should say, has a rocket launch scheduled for the Starlink satellites that are being put out into orbit to give the entire Earth internet access. And they're launching about 60 at a time. And the next one is scheduled for Sunday, May 17th at 7:53 in the morning. Last I checked, we will not be able to see it. Well, at 7:53 a.m., oh, that's UTC. I don't know what time that will be here. And they just changed it and added in the times. Should be 5 hours off from us. The good thing is if you go to Heavens Above, no, actually this Heavens Above puts it up after the fact. This rocket launch live site, you can click around, it'll give you more information, or pay attention to the news because Starlink 8, although Heavens Above is calling it Starlink 7, is due to launch on Sunday. And pay attention for times. If we're able to see it, it'll be in the news. And that'll be neat to watch. And it doesn't, the launch taking off would be cool to see. But as those satellites go circle, circle, circle around the Earth, getting higher and higher, you can see them not necessarily right at takeoff. So it's worth it to look it up, to keep checking back to see if they have more information, or to watch the live stream. So we also have some International Space Station crossings. Guys, this is 1 week, all the way to the 21st here. We have a ton of space station crossings. I immediately go to the brightness and I say, whoa, there's a bright one, -2. Whoa, -3.6. Whoa, a -3.8. The lower the number, the brighter it is. And then I check to see the highest point. And 90 degrees is straight up in the sky. Anything under 20, you probably won't even notice. It'll barely be above the trees. And I went through this list and I spotted a few that looked pretty good. This is May 15th, a -3. It's coming across at 9:25 tomorrow night. If it happens to be clear, it's going all the way up to 40 degrees. That's a really bright one. The next night, Saturday night, a -2.7. Now this is 10:17 p.m. It's going to go up almost to 50 though. This will be a good one to watch. And same with Sunday night, a -3.5. This one's going up to 73, almost the top of the sky. And that one's also at 9:25. That's a good time to go out and watch. Anybody can go to Heavens Above, put in your location and hit ISS, and it'll tell you the visible crossings. well, I put in visible. I don't want to see the ones I can't see. So I don't put the non-visible ones, meaning they're too high to be able to see, or it's daytime. So check for clear skies every evening. Amaze your family with all the cool things you know about in the sky. Just remember, there's a recording of this entire program on YouTube. It's in the NBTI channel on YouTube. That's actually the U46 Science Department. It stands for National Biodiversity Teach-In, but we house all of the recordings there. And the links you can find on the planetarium portal, which is pretty easy to find. Just go to the U46 website. Up here, there's always something that says departments. Click on that, go to the observatory, and right here takes you to the planetarium portal, where there's a page of resources where you can find links to all of the websites and images and animations that I used today. So let's go to the night sky. So I'm going to go into full screen mode. I have this set up for exactly right now. May 14th, 1:32 in the afternoon. But I don't want to wait until the sun really goes down, so let's make it happen faster. I'm facing west, so that means the sun rises over here in the east behind me, and it just crossed the southern sky, and it's going to come down and set in the west. Let's go even faster. Let's go even faster. Now it's 7:37. The sun sets at 8 o'clock tonight. It's 8:04 exactly. So let's keep going. Let's keep going. I wonder what the first thing is we'll be able to see. Getting closer to sunset. Sun's on its way down. Here we go. 7:45. Ooh, the sun's getting close to the horizon, almost completely gone. And Venus is showing up. Venus is the first thing you'll see in the western sky as it's getting dark out. Here we go. Down, down, down goes the sun. It's not fully dark out until about 9 o'clock. That's where we're going to go. But wait.
Mrs. Hernandez, I'm so sorry to bother you.
Yes.
We are seeing your PowerPoint and not the stellarium.
No way. Thank you
Yeah.
for interrupting then so I can get this figured out. So, okay, how about if I stop share for a moment? Let me try this. I don't want to not see my screen.
There we go. Now we see it.
Got it. Okay. We just hit sunset. It's 8:29. So it's 8:30. The sun went down at 8:04. Not only can we see bright Venus, but look, do you see that? Mercury is actually going around the sun just like Venus does, but Mercury is closer to the sun and it's going around and it's actually climbing higher each night. And at the same time, Venus is actually going closer to the sun. It'll be right in line with the sun on June 3rd. But there's going to be a point in the next few days where these two are going to be pretty close to each other. Let's go all the way to 9 o'clock, like when it's fully dark out. So here it is, 9 o'clock. And do you see that Mercury has disappeared? By the time it's fully dark out tonight, we won't be able to see it. But one cool thing about stellarium is I can fast forward. So let's go to tomorrow. Are you ready? So here's tomorrow, Friday night. Here's Saturday, Sunday, Monday, Tuesday, Wednesday, the 20th, Thursday, the 21st. Do you see how close those two are in the sky? That's what's going to happen next week. But do you see that the haze from the sun is still there? That's going to make these very hard to see. They're very low on the horizon. You want to be able to see the actual sun setting on the horizon, not behind a tree or a house or a building. But this will be something really neat to see. Venus and Mercury, it's called a conjunction when they're that close to each other. And that's going to be on the 20th and the 21st. And after that, they're switching spots. Notice that now Mercury is on the top and Venus is lower. And by June 3rd, we won't be seeing Venus at all. Okay, so I'm going to go back to today, the 14th in the west. 9 o'clock. Sun down, fully dark out. Fully dark, I'm going to go to 9:20. That is just beautiful. Do you see any constellations? We've got bright Capella in Auriga. Procyon is in the little dog. Castor and Pollux are in Gemini, the twins, up in the west. Their feet are heading right down towards the horizon. But does anybody see Leo the lion? Huh. Leo the lion, right here in the southwest. I'll draw the pictures in so you can see what it might look like if you use your imagination. This is facing west tonight at 9 o'clock. Castor and Pollux of Gemini, Leo the lion, and right up here, we also have the Big Dipper. It's up high, almost, well, pretty much kind of behind you, way up high in the west, northwest. So let's reverse that now. Go back to just stars. Now you're standing outside facing west. Turn your body to the left. Just spin to the left and you'll be facing south. These are the stars that we have in the south tonight. Bright Spica. Procyon's now all the way over to the right. Spica's bright, and Arcturus is also quite bright. Here's the lines. There's the names. There's the pictures. Arcturus is in Boötes, although it looks like a yummy ice cream cone to me. Corvus the crow, Leo the lion. Oh, Cancer the crab is right there between Gemini and Leo. Not a very bright constellation. Almost impossible to see from a backyard suburban sky. Let's spin to the left. So we're facing east. Now we're facing towards Chicago. There are two really bright stars, Vega and Arcturus. Spica is a third bright star as well. Spica's in Virgo. Vega is the brightest star in our summer sky in the constellation Lyra. There's the names of the constellations, and here are the drawings. Did you notice that the handle of the Big Dipper arcs to Arcturus and Spicon to Spica, just like we talked about last week? The Big Dipper arcs to Arcturus, and you can use it to Spicon to Spica. That's how you can identify those in the sky. If we keep going, we can face north. We almost did a full spin all the way around now. We're facing exactly north. I can see Venus again because Venus is in the northwest as it sets, but straight ahead of us in the north, well, Cassiopeia is right here low on the horizon, but the Big Dipper. Yes, that's the Big Dipper, not the Little Dipper. That's the Big Dipper. The Big Dipper is the one you see in the sky. The Little Dipper is harder to find. You can use the pointers. Follow, 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 and it takes you to this star that looks like it's all by itself. That's the North Star, and that is connected to Little Dipper. Here's the lines. And here's the drawings. Venus is right in the top of Taurus, the bull's horns. Taurus is already down by the time it's dark out tonight. One last thing before we go to questions, and we're just about there. If I go east, if I face east, you know, that's where the sun comes up in the morning. I'm in the opposite direction from when I was watching sunset. I turned around. Now I'm going to fast forward a little bit. I want to go all the way to sunrise. 1, 2, 3, 4. It's about 4:30 in the morning right now. Hey, at 4:30 in the morning, I can see Mars and Saturn and Jupiter. And there's the moon. Now, if I zoom into the moon, it's going to look like that tonight. It's a little bit smaller than half. It's a waning crescent moon tonight, meaning it's a little bit smaller than half, and every day it's getting closer to the sun, which means it's getting smaller, smaller, smaller. So there's the sun, there's the moon. The sun is right behind it. I mean, you can see the glare from the sun right there. The sun is about to come up. Mars is right next to it, and Saturn and Jupiter. And tonight, the moon is right next to Mars, or I should say tomorrow morning. And if we were to go back in time, watch where the moon was on May 10th. That's where the moon was at 4:30 in the morning on May 10th. And here's where it was the 11th. On May 12th, it was right by Saturn and Jupiter. There's the 13th. Here's the 14th. Tomorrow morning is the 15th. Can you guess? Can you predict where it will be on the 16th? If you were thinking here, you're correct. And here's the 17th and the 18th. Hey, can you tell that it's headed to where the sunlight is? Every day the moon's moving a little bit closer to the sun, and we will be at a new moon around the 21st. We even let the sun come up. Here's May 21st, a week from today. We're gonna let the sun rise. Yay, here comes the sun. It's daytime. You can't see the stars anymore. But wait a second. If I pause here at sunrise and I could get rid of the bright glare from the sun, the moon is right next to the sun. Hey, I couldn't see that when it was daytime. That's because when the moon is near the new moon phase, when it's going to be crossing right underneath the sun here, we aren't able to see it in the sky because the brightness from the sun is too bright. But we do have the moon, and Mercury and Venus are right behind the sun today. Tomorrow, either one. So let's stop here and answer some questions. I sure hope you guys have some questions. I would love to try to show you some of the answers.
Hi, Mrs. Hernandez. The first question we have is from, it says, hi, my name is Angelique. How was the moon yesterday? I think maybe this question came in early. I'm thinking she's wondering which moon phase.
Well, today is close to the last quarter moon. It's a little bit smaller than half. So that means yesterday, since it's getting smaller every day, yesterday it was a little bigger. Here, I can zoom in and show you what it looked like yesterday. 16, 15, 14. Yesterday was the 13th. And you couldn't see it at this time because look, the sun is up. Well, I'm sorry, that's not true. The moon is up at the same time as the sun. And if we were to zoom in on it with, like, say, a telescope, ta-da, that's exactly what it looked like yesterday. And you might have been able to see that in the sky. It's about a half moon. That actually looks like a little bigger than half. So we're probably at a quarter moon today, or maybe a slightly less than the quarter moon, which is also known as a half moon. So that's the size we were just at.
Wonderful. What happens to the stars during the day?
They're there. You can't see those? Oh, that's because it's daytime. Well, the sun is way closer to us than those stars. Stars at night are in the background. They're way behind the sun. But the sun is so bright. It's like somebody holding a bright flashlight right next to your eyes. And when somebody does that, you usually can't see the wall behind that person because the sun is so bright. But the cool thing about stellarium is I can show you what would it look like if I could block off the brightness from the sun right now. And by the way, this is 7:30 in the morning. This is daytime. During the daytime, if I get rid of the brightness, ta-da, the stars are right there where they've always been. We can see the stars at night because the brightness of the sun disappears along the edge of the earth. During the day, they're still there. We just can't see them with our eyes. That's a good question.
How long is a year on the moon?
A year on the moon, believe it or not, is the same as a day on the moon. The moon goes around the earth once a month, and it also spins once every month. So a day and a year are the same on the moon. And it's about 28 days. It takes the moon 28 days to go all the way around the Earth and be back in the same spot. Hey, we could check that. If we're set up right now for May 13th, here's where the moon will be on May 14th. Here's May 15th, 16, 17, 18, 19, 20, 21. Can you see that it's going right past the sun? But wait, it keeps going. It's still there on May 23rd. Now it's over here. And here it is on May 24th, May 25th, May 26th. Hey, where'd the sun go? Well, it's behind me now. I'm facing the wrong direction. And it's going around the backside of the Earth. So why don't we skip forward all the way to June 13th and look what's there again. The moon is there again. It takes 28 days for it to go all the way around the Earth, and it shows back up in the same spot a month later, about 28 days.
That's really cool. I never thought about that before, about that question. Which planet spins the fastest? And I'm thinking, I know that's sort of a Google question, but I think it gets to a bigger scientific point.
Yes.
Planets spin at different rates, and why do they spin at different rates?
Yep. And I think it's tempting to think about that and think, well, the smallest ones probably spin the fastest because, well, they're small and they're easier to spin. But it turns out Saturn, now I don't have Google in front of me, I'm almost positive Saturn spins the fastest. If you were on Saturn, if you could go to Saturn and stand on Saturn, which you can't because Saturn's made of gases, but if you could, a day on Saturn is 10 hours. You would have 5 hours facing the sun, and then it's bedtime. And you go to bed and it's dark for 5 hours, and then it's daytime again. And then it's light for 5 hours, and then it's nighttime again. Every 5 hours, it switches from daytime to nighttime because one whole spin on Saturn is only about 10 hours. That's one of the reasons why scientists think that Saturn has so many rings. That blob of gases is spinning so fast, it's starting to bulge out in the center. I guess you could say it's kind of like flattening out. Excellent question.
Here's another really good one. Do shooting stars happen at daytime?
They definitely do, but we don't always see them because they're not bright enough. We do. We have shooting stars or meteoroids that burn in our atmosphere. Happen every single day. There's a couple every single hour that burn through the sky over planet Earth people. But we usually only notice them at night. Now there are some videos, you can see them on the internet. There was one on Valentine's Day, February 14th, a few years ago in Russia. And at 9 o'clock in the morning when the sun was up, you could actually see a shooting star going through the sky. In the day, it was so huge and bright. Mm-hmm. So definitely, we get shooting stars in the nighttime and the daytime. It's just way easier to see them at night.
I think you struck a lot of interest with Pluto. There seems to be a lot of interest in Pluto. Can you walk on Pluto? I'm going to give you 3. Can you walk on Pluto? What is Pluto made of? And how long is a day on Pluto?
Okay. Can you walk on Pluto? Well, no, because we can't get a human out to Pluto because it's way, way, way too far away. But if you mean if we could send a human there and if we could keep a human alive in a rocket that long and make it all the way to Pluto, yes, it's made of rock. We have pictures of it. There's lots of frozen material also on Pluto. Yes, it's a hard surface. It's not like a gas giant, so you could walk on it. What's it made of? Well, we know that it's made of rock and some other reflective material, probably frozen things that on Earth are usually a gas or a liquid, some of which is water. And how long is a day on Pluto? I don't know. I would Google that if I needed to know that. That's a Google question. And I don't have it memorized, that's all.
Yes. We have a follow-up question to this shooting star question. How large could a shooting star be?
Well, they can be anything. Some of them are as small as a speck of dust. Seriously, a speck of dust. Or imagine one piece of salt from your French fries. That's how small the rocks can be that enter the atmosphere, and they burn super fast, and they're very, very small. But we can have bigger ones, a rock the size of your fist, or a basketball, or a garbage can. Or we could have a rock the size of a car, or even bigger. Now, most of those big ones hit the earth a long time ago. Oh, a billion years ago, big rocks were hitting the earth all the time. But we have been impacted so many times by so many rocks that each one makes the earth a little bit bigger, that there just aren't that many big rocks loose out there in the solar system than there used to be. So it doesn't happen very often that big ones come through the atmosphere and burn up and actually land on the earth. But it can happen. They can be big. The biggest one recently was that one in Russia that I just mentioned.
Why do we only see one side of the moon?
Because the other side is facing away from us. Kind of like if you're at home right now and you turn and you look at your mom or your grandma or your brother or your sister or your uncle or whoever's there with you, and you say to yourself, why can I only see the front of your face and not the back of your head? Because when they're facing you, that's the part you can see. And our eyes can't telescope around and see the backside. So the moon, we only see one side of the moon. That makes it look like a circle in the sky when it actually is three-dimensional. It's actually round, like a ball.
Is time slower on the moon?
No, time, 1 second on the moon would be same as 1 second here on the earth. That's a good question. I think that's what that means.
Yeah, I think so too. That's how I interpreted that question. It's a good question. More about the moon. So Pluto and moon seem to be most popular today. How old is the moon?
The moon and the earth are about the same age, somewhere in the 4 billion year old range. Many scientists think that the moon formed when something really big smashed into the earth. Remember, I said really big things smashed into the earth all the time, billions of years ago. A really big thing smashed into the earth. It hit it so hard that some of the molten magma, like molten rock, like hot lava, it kind of catapulted it out into space. And that piece of rock, molten rock, cooled off and became the moon. And instead of escaping and like going in a straight line forever away and away, it got captured by the gravity of the earth and it started going around the earth. So it's made out of the same exact rock as the mantle of the earth, and it goes around the earth once a month.
Nice. So we have another question. This is the third question by Evelyn, which is, she's giving some really good questions here. And it's is the sun ever cold? So it might be maybe a good time to talk about like the cycle of a star, or the cycle of something like a sun.
Yeah, is the sun ever cold? Not if it's a star. All stars are undergoing something deep inside in the middle of it called fusion that gives off huge amounts of heat and light energy. And that's what makes it a star. Now, if a star stops doing that, there are reasons why it stops. It stops giving off heat and it stops giving off light, and it's just material hanging out in space. And we don't call that a star anymore. We would call that a nebula. So if it's a star, it's always giving off heat and light. But stars do have a cycle, a pattern of things that happen. And when that star stops doing nuclear fusion, it stops being a star.
Mrs. Rossi Googled for you.
Yay!
Pluto, a day on Pluto is 6.4 Earth days. So 6 days, 9 hours, and 36 minutes is
a day on Pluto.
A day on
about 7 Earth days.
Mm-hmm.
That means you would have continuous sunlight for about 3.5 days. And then when it got dark out and you had to go to bed, you would have to sleep for 3.5 days until the sun comes up again.
And this also now, I know Pluto isn't a planet, but that also challenges our sort of thought process on smaller objects might spin faster. And
Yeah.
in this case, you know.
It spins
Yeah.
way slower than the Earth.
Yeah.
Faster. I wonder what makes them spin faster or slower.
Or slower, right? I wonder if
Good
it.
question.
I know that might be a fun thing for us to, investigate some other time. Okay, so I think we have time for a couple more questions. Why is Pluto red? The red planet.
Well, it's not the red planet. Mars is called the red planet because Mars has some iron on it, but we have found in 2015, just a couple years ago, when we sent New Horizons out to Pluto to take pictures and we enhanced them, it turns out there are parts of Pluto that definitely have a reddish hue to them. So we can go back to that picture. It's absolutely amazing, the imagery that we've had coming from New Horizons. And I can go back to that picture. I think I have several of them. So it is that rusty reddish color, and it is kind of this cream, sort of almost brownish color here. This is like a huge glacier right here. This is all frozen material right there. And those things reflect light back to our eyes from the sun, and we perceive different colors. So yes, it has colors because it has colors.
Sorry, I have my mute on. Here's a really interesting question. It's a beautiful planet, by the way. It's so pretty, but this kind of goes to this. It says, what is your favorite fact about the moon? Do you have a favorite fact about the moon?
Favorite fact about the moon. My favorite fact about the moon is that the thing I was amazed most when I first discovered it was that if you watch the moon several nights in a row, if you can see it, and there's only certain times of the month where you can see it in the evening sky, you can predict where it will be the next night. And it's actually really fun to find out when you're right.
I like that. I like that a lot. So it's that whole observational skills, really important as a scientist.
Yeah, and I didn't even know I was being a scientist when I discovered that. It was really cool to watch the moon move from night to night and know that you can predict and know that it'll be back again 1 month later.
Yeah, yep. That's awesome. Why does gravity pull you down, and why does the moon have no gravity?
Okay, excellent questions. The moon, gravity doesn't pull you down. I'm not exactly sure. I think that's a wording thing that gets out there. Gravity is a force that pulls. I didn't say pulls down. Gravity is a force that everything has. Everything that's made out of matter has a gravitational pull, and it pulls towards it. And it doesn't matter if it's a piece of paper, or if it's a pony, or if it's a planet, or if it's a necklace. All of those things are made of matter, and they all have gravity, and it pulls towards that object. See, the thing is, gravity isn't really strong until you get to an object that's really huge, very massive, or if you're really close to a massive object. We are so close to planet Earth, we feel the gravity of the Earth pulling us down towards the center of the Earth. And I think that's where that comes from. On Earth, it always pulls us down towards the middle of the Earth. There's gravity everywhere because everything has gravity. And that's another misconception that comes out. I sometimes hear people say, well, since there's no gravity in space, you just float around. Not true. There's gravity everywhere. But if you're really, really far from massive objects, the farther you get, the weaker the pull. So if you're really, really far from a star, you're not going to feel the pull of that star. But if you get closer and closer to it, you will feel the pull of that star. The moon definitely has gravity. We have pictures of astronauts walking on the moon. And if there was no gravity on the moon, they wouldn't be able to walk because they wouldn't be pulled down to the center of the moon. That's how gravity works.
That was a really good explanation. And Evelyn has kind of I think it's a follow-up comment. What you're describing to her reminds her of working with magnets and how the forces, I know it's a different force, but how the forces pull together. And so that's a great.
Yeah, there actually are a lot of similarities. As a matter of fact, magnets, the closer one is big. If you have two magnets and you get them closer and closer, they pull together. Now, if you hold them away from each other, they don't do anything to each other. But you get to a certain point where they're so close that they both pull towards each other and then they end up stuck next to each other. So the closer you get to a magnet, the closer you get something made of iron near a magnet, the stronger the pull gets. Yep.
Yes.
And the same thing works with gravity of objects in space.
It's all forces. So, you'll be learning about forces in all of your classes. We in physical science, we work on forces.
Yep.
I like that one. Do you, we're a little bit over, but do you mind one more question? And
Let's do one more.
Yep. Because I've never heard of this. Why is there a hexagon on Saturn? I don't know where would be the hexagon?
I don't either. Never heard of it.
Okay.
Saturn. There's a close-up view of it. There's another one. Let's go. That one. And a hexagon. Ooh, help me out, you guys. Is that seven-sided? No.
So yeah.
I just don't see a hexagon anywhere. There's none on Saturn. That's not true. It's not a thing. There's no fact in that.
Okay. So maybe it's just something we saw somewhere. Oh, it says in the top. It's on the top.
Up here. I know there's some bright flashes of light we can see, almost like northern lights, electrified matter, but I've never seen it in the shape of a hexagon. So it's not like there's anybody up there making it in the shape of a hexagon. If there ever was a hexagon of those luminescent particles, I've never seen that though.
Well, so for sure, I think you and I will probably be doing a little research on that one to learn a little bit more and see where that one comes from.
Yeah.
It's kind of interesting. And just really quickly, I know we said one more, but do planets break?
Do planets break?
Yes.
No, planets don't generally break. Now, when you say break, does that mean like when you take a toy and you like slam it onto the floor and it breaks? Like, or do you mean like a computer program and you can't get it to work and it's broken? Or it depends on what you mean by break. If you mean like suddenly spontaneously explode all by itself, no, that's in science fiction. When people make things up about planets exploding and breaking, in real life, planets don't break. We even had a comet run into Jupiter in 1995, Comet Shoemaker-Levy, and it did not break Jupiter. The comet just became part of Jupiter. It actually sunk underneath the gases, and those parts are still inside of Jupiter, but it definitely didn't cause it to break. And they never, ever, ever smash into each other because planet orbits never, ever, ever crisscross. That's a rule for a planet to be a planet, is that it must never, ever crisscross any other orbits of other planets. So they cannot smash into each other. And you can imagine that. And then we call that science fiction because you're making that part up in your head, and that's not something that really happens. It might make a cool story about planets smashing together, but in real nonfiction science, that doesn't happen. It's physically impossible.
Yeah, science fiction is really fun. And so, yeah, they wouldn't break and they wouldn't collide because they're not on the same orbit.
Yeah, they could never collide. That can't happen because they're not ever on the same road together, their orbit.
Well, thank you so much. Do you have any last words, or we're gonna be doing this? We're gonna be doing this Thursday, right? Next Thursday, but
Yeah,
doing something special. We're not sure.
next week is officially the last distance learning for this school year. I think it might be at a different time. We're going to do a history of the Elgin National Watch Company connection to the Observatory Planetarium of U46. So it might be a little later in the evening. It might be at this time. We're not exactly sure of the time yet, but we'll be posting it on Facebook and emails and on the planetarium portal. So
Yes, and if you don't want to miss it, a good thing to do is to check out our Facebook page or our planetarium portal, and then also just go in and like our YouTube channel, National Biodiversity Teach-In, and anytime we're doing anything live, it's going to pop up on your notifications, and so you won't miss any of the scientists or planetarium stuff that we're doing. So, well, thank you very much. That was really great.
You're welcome.
To see everybody again next week.
Thanks for all your good questions, everyone.
We're good, very good questions today.
Yep.
Bye.
Bye-bye.